quantity will have magnitude and direction. Okay, now vector has a magnitude and direction. So when we write vector, this is A, we underscore vector A equal to, this is a vector. So it will has a magnitude and the direction of it. Okay, magnitude and the direction of it. Okay. So graphically, you can see as the following. Starting with the term here, we have 0, O, okay, and then we measure from the datum to this arrow A, okay, that's how we write. And then when the figure has the value, for example, 10 newtons and the degree 50 degrees, so we can say that this vector has a magnitude of 10 meter, and then with the angle of or the direction of 50 degrees. Okay, that's how we. And then what we did also last time is about the parallelogram law of addition. We have shown to you the vector component. Okay, in order to go from 0 to v, you can have to do the vector addition, which is p plus q or q plus p. Okay. Similarly with this one, the vector v, you can have p plus s or s plus p. Okay. This is very straightforward. Okay. And this is how we resolve vector v, okay, into a rectangular component. So you can have v to be v, vector v to be vx plus vy. Okay, and then you can find the unit vector of it. When we write this equation in terms of unit vector, so unit vector means a vector whose magnitude is equal to 1. So for this one, this is I, this is J. Okay, we have done this one in static before, so we can write here, and to get the velocity equal, you can write in terms of unit vector I, and then plus Vy J. Okay, this is equation 1.2. And then what we have done last time, we can resolve into sine and cosine. Okay, this is I put how many star last time. This is many star, meaning very important. How do you resolve using Cartesian coordinate vector? You can resolve into x and y in terms of sine and cosine. So you can have here this value Vy is V sine theta, and Vx is basically V cosine theta. Okay, so make sure you do not mix up this one. Okay, this is what we call vector using Cartesian coordinate system. Okay, and the rest shows you the component of Vx. Just now I Vx will be cosine theta and Vy be sine theta. And then for you to find the magnitude and the direction of V, you square root of both, which is Vx squared plus Vy squared, you square root of both, and then you find the angle theta here, which is inverse tangent. Theta will be inverse tangent of this value. Okay, inverse tangent. in the standard of this value. So you can get the value of theta. Okay, this is an example. Okay, we try to do one example. Make it clear. Okay, this is what we call a dependent motion. Okay, we have here arm AB. This is arm AB, from A to B, and then look at the figure here. We have X and Y. We take here as a datum. So to the right is positive, going up is positive. Okay, positive, positive. Okay, and then you are given the distance here. Okay, the unit is in meter. 400 meter. From G to B is 700. And then C to B, B is in the middle, so we have 500 each. Okay. So what happened to this arm? This arm is initially at rest, okay, with initial position x equal to 0. So these are the information given. So crane arm moving to the right, okay, moving to the right with constant acceleration. So constant acceleration given here 2 meter per second square. Okay. Okay. So it is initially at rest at position 0 and then it move to the right. So given here all dimensions are in millimeter. So this is in millimeter. So look at, make sure the unit, yeah, make sure the unit. Given here all is in millimeter. Okay. So we need to convert lah because the acceleration is in meter per second square. So what you need to do here? First thing, question A, okay, ask you to find what will be the acceleration of point A, what will be the acceleration point A, point B, point C, point B, and point G. Okay, and then find the velocity of each of these points after 1 second. Okay, you need to find out the velocity of each of these after 1 second. To find acceleration, and then from there you can integrate acceleration, you can get velocity. Okay? And then you substitute the value of time with 1 second. Okay, and then what will be the position? Okay, so you have this, we do the integration, and then to get this acceleration, you integrate the acceleration, we get velocity, and then you integrate the velocity, you get the position. Okay. S or can be X. Okay. Okay, and do the integration. So knowledge integration very important. So first thing you need to understand the question. And then as I mentioned last time, make sure the unit. Okay. And then you need to know exactly what you are looking, what you are trying to solve. Okay. This is example 1.1. Okay. Let me see this one. 1.1. This is an example. This is another example. We have the equation x3t squared plus 1.5. Okay, so you want to find the velocity. Okay, So start with this one. This is another example. Just want to show you the general thing that we are trying to do for this class. So we have this basic equation, xt squared plus 1.5. Okay, I enlarge it so you can see. All right. So you differentiate with respect to time. So you differentiate dx dt. Okay. So dx dt you get 60 plus 1.5. This is very easy, straightforward almost. And then again you differentiate with respect to time. Okay. No other t here, so you only t. Okay. So we have the unit here. This is meter square. Okay. And then you want to substitute if you are given what will happen after 4 seconds, for example, t equal 4. So just substitute the value of t into here. Okay. T 4 seconds, t 4 seconds. No need to have a substitution because we have only a constant here. Okay. Okay. So you get to substitute the value, so you get the value of x equal to 54 meter. Okay. So 54 meter, you can sense the distance of 54 meter, 100 meter, 100 meter you sprint. So half of the 100 meter, 50 meter. Okay. And so then you get the answer.
Doktor, sorry mencelah.
Yes.
Maaf mencelah. Slide ni doktor ada send kat kami ke tak ada?
I think I have given in Google Classroom, maybe you can check. But if not, I will give to you. I will give today. No problem.
Okay. Thank you.
Okay. This is how we can get the value of x and velocity and acceleration. Okay. After that, after we have described that, we get the value of x, we get the value of the velocity and acceleration. Okay. Can we plot this graph? The graph of x, graph of velocity, and the graph of acceleration. All of that with time, velocity. Okay. Okay. So starting with this equation. Okay. This equation, we learn in mathematics this one. If t square, so how it look like. You solve this one, t square. Okay. You equate this one equals 0, so you can plot the graph. Okay. This is concave down. Concave down. And so you can plot the graph. And then you differentiate, you get the velocity. So we only 60, so this is linear. Right? Linear. So 60 cut at the y-axis at 1.5. So it will be like this. Okay. And then this is velocity. This is the value of x. And then for the acceleration, this is constant, so 6. Okay. So we can plot the graph of position, displacement, velocity, and acceleration. Okay. All right. What else I want to highlight here? We have mentioned also last time 2D, and then now we move from 2D to 3D. Okay, for 3D, before we have X, Y, and Z. Okay, so X, Y. Now for 3D, we have Z. Okay, so we also have the what we call the angle, directional angle. Okay, so theta X, theta Y, and theta Z. All of these, that's why some students ask me where to get all of this. You have to refer your fundamental in static. Okay, so that's the prerequisite for this one, how to get this one, what are the questions to be used, okay, how to get this. So we start having this vector, we write this vector in terms of v. Okay, we can write vx, v equal to vx in terms of unit vector, okay, vy, okay, plus vk. Okay, okay. How to get the direction of cosine? This one we call what you learned in static before, direction of cosine. So what is direction of cosine? For direction of cosine, okay, which is 110, you start to, for example, we talk about cosine theta x, okay, cosine theta x, this is direction of cosine. Okay, so cosine theta x equal to v vx divided by v. Okay, which v we are talking about? We are talking about the magnitude, okay, the magnitude of v, okay, which is this one. So how to get magnitude of v? So you square root all of the value of vx squared plus vy squared and vz squared. Okay, this is how to get magnitude. So in order for you to find the direction of cosine, if cosine theta x, cosine theta y, and cosine theta z. So you take Vy divided by V, cosine theta z is Vz divided by V. Okay. All right. Let's proceed another one. How to express a vector using its unit vector u. Okay, this is very similar to example in the previous slide or note that I have given to you. Okay, the example, and this is the fundamental of how to solve the problem. Okay, because this time we have to express a vector using its unit vector u. Okay, so unit vector u. Let us take these 2 points. 2 points. We have point here, point P, and then another one, point Q. Okay. It can be any point in the rectangular coordinate system. So we have the x, y, and z. Okay. X, y, and z, we have origin 0. Okay. So these 2 points, I want to express in terms of the unit vector of these 2 points. So first thing, what you need to do is the value of r, we write this one in general form. General form, r equal to rxi plus ryj plus rzk. And then I can write in terms of general form. So it's going to be r, vector r equal to, okay, r, okay. So what is the value of r here? The value of r here is the square root of Rx square plus Ry square plus Rc square. Okay. Okay. That one clear. And then you need to define what is U. Okay. Unit vector U. So unit vector U equal to, look at here, PQ, from P to Q. So PQ, vector PQ, okay, this is vector, I underline, and then you divide by the magnitude of PQ, okay, magnitude of PQ, okay. So how to get vector PQ? So to get vector PQ, we have to subtract x2 minus xi, okay, y2 minus yi, and then z2 minus zi. So you get vector PQ. Okay. If I say the vector QP, so how to subtract that one if the vector this time is QP? So what to do? What will be the value? Anybody want to try? If PQ is x2 minus x1, if I write, if we want to get the opposite direction, which is QP, so what will be the value?
x1 minus x2.
So it's going to be opposite way, right? So it's going to be x2 minus x1 minus x2, y1 minus y2, and z1 minus z2. Okay, so you must understand the direction. Okay, if we flip the other way around, so we need to identify which one is head and tail. Okay, so this time we say PQ, so P to Q, so you have to get the vector of it, you have to subtract head to tail. Okay. All right. This is how to express the unit vector. Okay. Now we want to do this example. Okay. This example, we want to apply the one we have, the concept that you have learned just now. Okay. To this example. Okay. Example 1.1. Okay. Example 1.1. Okay. We have two vectors. Vector A directed along OP. Okay. Directed along OP. We are given here vector A, and then the magnitude of it is 221. Okay. Directed along OP. How about B? This is B. B directed along DE. Okay. This is DE. Okay. And then the magnitude of B is 489. Okay. We need, I would say this is a millimeter. Okay. So express each of these vectors in rectangular component. Okay. Okay. You need to refresh what you have learned in static before. So it's being given here. Okay. the position of each one of those. Okay, given here this is 18 in x direction, and then 8 in y in z direction. Okay, and then 0 in y. This is 6 and 8. Okay, all right, and then the height of this one we are given. This is 9. This is 10. Okay, so we want to express each of these vectors. Okay, each of these vectors. Okay, say this one we want to get the direction to write vector A as a combination of its magnitude. Okay, so we want to have the direction of U O P. Okay, okay, U O P. Okay, the direction U O P. So first equation you need to write is what? Is this one. Okay, so you write vector A. Okay, this one equal to the magnitude of it, which is here, is given, and then unit vector OP. Okay. Okay. So this is known. This one we want to find based on the position given here. Okay. So you need to know from OP. This is 0, 0, 0. So this is position P. Okay, position P. Okay. So you write this down. What is position P here? X1. Remember X1, X1, Y1, and Z1. This is 0. So minus. So you have here, this is 18. And then you have Y is 10. Okay, 10. And then Z. Z is 8, right? So 18 minus 0. 10 minus 0. Then 8 minus 0. Okay, so you get this one. 18I, 10J plus 8K. And then you divide by OP. Okay, the magnitude of this one, which is 18 square plus 10 square plus 8 square. Okay, use your calculator. What do you get? Double check. Check this value. 18 square. Let me have a scientific calculator. 18 square plus 100 plus 64. So you square root of that, you get 22.09. 22.09. Okay. So we run off. So you get 22.1. Okay. So this is the answer for unit vector of the direction along OP. Okay. This is how we get. Okay. Okay. Did we finish yet? We didn't finish, right? We didn't finish yet, right? Because you need to solve what will be the value of vector A. So now we want to find vector A. So vector A, you have to multiply magnitude times unit vector. Okay, so you proceed to get what you have obtained just now. 221 divided by 22.1. So 10. This is 1, this is 10. So you get 180i plus 100j plus 80a. Okay, so we have done this part. Okay. Okay, now it's your turn. Your turn. I want you to try vector B. Okay, try on your own for vector B. Use the same thing, same way that we are doing. Okay, do this. I'll give you a few minutes to do this. Okay, 3 minutes is enough. Okay, now find vector B. For vector B. Okay, find vector A just now. Now we want to find vector B. B. Okay. Vector B. Okay. Same thing. You have to do the same thing. Okay. Write the coordinates. Okay. Coordinate of E. And then the coordinate of E. Coordinate of E and coordinate of D. Okay. And then you deduct E minus D. Right? Okay. U, D, E. So what is the coordinate for this one? Anybody want to tell me? I say this one is 1, Y1, V1 for this one. And this one, I say the X2. This X1. Okay, so what is the value of this one? Coordinate?
18, -9, and 8.
18, 9, 8. Let's check. X value. Okay, this is X. 18, okay. And then for Y, display, no? Display. Okay, -9. Okay. And then Z. C. Okay. How about this one? D. D. This one positive, so going down. Anybody want to try?
-10.
-10. X. This is X.
Yes.
X. Okay. -10.
0.
Okay. Y is plain. 0. How about Z?
-6.
So what we are going to have a lesson learned here is the coordinates. You have to make sure the coordinate that you write is correct. And if you wrote down the wrong coordinate, you're going to get the wrong answer. Right? So make sure you really understand the coordinate system, plus or minus, which one is better. Okay. So that one is very important. Okay. So start with this one. We have again this one go x. Okay, let me make it smaller. So 18 minus 10. So plus. So 18. We have here 18. This is x2. 18. This is minus 9. This is 8. Okay, and then we have here minus 10. We have 0. We have minus 6. So meaning our coordinate of x1, y1, x2, y2, z2 square. Okay, this one also for coordinate at D also we have done this coordinate. So you find the difference. Okay. So 18 minus 10, so plus. So 18 plus 10, 28. And then minus 9 minus 0, so you get minus 9. And then 8 minus 6, so 8 plus 6, 14. Okay. And then you square root of that, of PE, so 28 squared plus 9 squared plus 14. Okay, use your calculator again. You check. Okay, for scientific calculator, 28 squared plus 81 plus 14 squared. Oh, 32 point, what do you get? 32 point?
32.57.
32.57. So we round off, we get 32.6. Okay. Alright, so we have here BE, U, we haven't done yet. Now we want to multiply B, vector B. Okay, hold on a second. Somebody is. Okay, we proceed. Now we proceed to get the value of B. Okay, vector B. So given in the problem, vector B, the magnitude of it is 489. So you multiply the unit vector DE just now. So you get 489 divided by 32.6. So this is the value for I, J, and K. Okay. All right. So point that you have to take note here. In order for you to get the unit vector U, first thing that you need to do is you have to identify what will be the coordinates okay, the coordinate of the corresponding points. Okay, you need to write down the coordinate for each point that you want to find. Okay. All right. We take 5-minute break and then we come back at 11.